All right, after alcohols, now we have ethers. Ether is ROR, where R is just our general term for the rest of the molecule. R generates that this oxygen here is bonded to a carbon, and that carbon is a normal sp3 hybridized carbon. It's just a normal alkane-like sp3 hybridized carbon. R prime just means that this R could be the same or different. An example is diethyl ether, CH3, CH2O, CH2, CH3. That is an example of an ether, diethyl ether. And like I said, we'll get into the naming of them later. An amine, NH3 bonded to, or nitrogen bonded to 3 hydrogens, and nitrogen bonded to 3 things is an amine. So you can have NH3 as ammonia. You could have nitrogen bonded to 2 hydrogens and 1 other R group, like a CH3. That'd be a primary amine. Nitrogen bonded to 2 R groups, such as a CH2, CH3 on one side, a CH3 on the other side. This is a secondary amine. The nitrogen bonded to 3 R groups, 3 normal carbons, that's a tertiary amine. Now, this is something very important because people mess this all the time. Recall that with an alcohol or an alkyl halide, you look at how many carbons that the carbon containing the OH is bonded to. You're not looking at the oxygen to see how many carbons it's bonded to. That'll always be 1. So for an alcohol or an alkyl halide, you say, okay, there's my OH group. Here's the carbon that's bonded to the OH group. How many carbons is this carbon bonded to? This carbon is bonded to 1, so this is a primary alcohol. Okay, for example, this is a tertiary alcohol because that carbon is bonded to 3 other carbons. But amines follow different rules. With amines, you look at the nitrogen. Is this a primary, secondary, or tertiary amine? This is a primary amine. Note, it looks the same. Wait, we've got this, the 3 CH3s, the carbon and OH, the 3 CH3s, the carbon and NH2. Why is this tertiary and why is this primary? This is tertiary because with alcohols and alkyl halides, we look at the carbon. And this carbon is bonded to 3 carbons, tertiary. With amines, you look at the nitrogen. This nitrogen is bonded to 1 carbon. So it's primary. Make sure you get that straight. Okay. Let's look at the functional groups now that have the carbonyl in them. Carbonyls spice things up, make it a little bit more fun. If you have a carbonyl with a normal carbon on one side and a hydrogen on the other side, so the carbonyl carbon is bonded to 1 hydrogen, that is called the aldehyde functional group. Note, we said before, this is RCHO is how you abbreviate it. Here's 2 examples: formaldehyde, acetaldehyde, benzaldehyde, our favorite aldehyde right there. All right, aldehyde, a carbonyl carbon that is bonded to a hydrogen, at least 1 hydrogen. Ketone, the carbonyl carbon is bonded to 2 normal sp3 hybridized carbons, RCOR. So, for example, CH3, C double bond O, CH3, acetone is a ketone. Carboxylic acid, very common functional group, where your carbonyl is bonded to an OH. Note, this is kind of like you stuck a carbonyl in the middle of an alcohol. Recall the alcohol was ROH. Carboxylic acid is our carbonyl OH. So acetic acid, you've used acetic acid before, that is an example of a carboxylic acid. And note the various abbreviations for those carboxylic acids. All right. Remember how an ether was ROR, 2 normal carbons bonded to an oxygen? Well, what if we made one of those carbons a carbonyl? R carbonyl OR. That makes it an ester, and it's a different functional group. These carbonyl groups, put them in there, totally change how these functional groups react. All right. So R carbonyl OR prime ester can be written RCO2R prime, RCOOR prime, and I actually will recommend this. I'll give you life tips throughout the semester. One is, everyone wants to have a cool name for their kid. So everyone's got crazy cool names coming on. If you like the traditional names like Esther, everyone has an old Aunt Esther. Esters are nice traditional names. If you want to spice it up, you like the tradition, but you want to spice it up, name your next kid Esther. So you've got Esther, but spell her name RCOOR. Now, I grant you that the first day of preschool and kindergarten, the instructor is going to be like reading the names, and they're like, okay, Arcour? And then your little kid says, no, that's Esther. And you're like, teacher, look, Esther, RCOR. Oh, I get it. Yes, RCOOR, Esther. And then they won't forget it from then on. So do that. Name your kid Esther, but spell it RCOOR. It's just a nice, jazzy, scientific way of naming your kids, even if you like the more old-fashioned pronunciations. Okay. Amines. What if we take an amine, an NH2, but instead of just the R group next to it, we put the carbonyl? Well, then we'll have an amide, or an amide, or an amide. No one knows how to pronounce it, so you hear it all the time. Unless you're in Great Britain. In Great Britain, it's amide, amide, amide. It's always amide in Great Britain. But everywhere else, it's an amide, amide. You just have to know all the pronunciations. R carbonyl N. And note, you can have two hydrogens on the nitrogen. You could have one carbon bonded to it, two carbons. So you could have primary, secondary, and tertiary amides. All right. There are some other functional groups that we don't worry about too much, especially not till next semester. Next semester, we'll worry about nitriles, where you have C triple bond N. RC triple bond N is a nitrile. Thiols, carbon bonded to an SH. Nitro groups, carbon bonded to an NO2. Those are other functional groups we'll deal a lot more with in the next semester of Organic 2. All right. So, well, that ends the functional group. I'm going to cut this video off now, and then we'll go into the physical properties and molecular structure of organic compounds and how it relates to these functional groups.